Okay, everybody. Sorry, I'm going to zoom in a little bit here. All right. Guys, if you factored this or did the quadratic formula, you would get x equals -4, and you would get x equals +1. Okay, so if you solve that. So, -4 is a solution of x squared plus 3x minus 4. -4 is an x-intercept of the graph of y equals the same expression. If you replace 0 with y, it becomes a graph because now you have ordered pairs of numbers. -4 is also a 0 or a root. So just all those different words are kind of interchangeable. Also, if -4 is a solution, that means x plus 4 is a factor of the polynomial. So make sure you understand all those things real quick. So here I'm given 3 factors of a polynomial. This is in factored form. So first of all, to find the zeros, I set it equal to 0, okay? And then I do x plus 1 equals 0, solve that. X minus 1 equals 0, solve that. X plus 3 equals 0, solve that. My solutions are x equals -1, x equals 1, and x equals -3. Okay? So the zeros, or the solutions, or whatever you want to call them, are -1, 1, and 3. Okay? All right. The zeros of this function are -2, 5, and 3. Okay? All right. Now, I've got to write a polynomial in standard form. Hey, how are you?
I'm going to keep my distance. Peyton Wood discussed the topic.
Okay.
I sit beside him first period.
Huh. All right.
I thought you would like to know too.
Yeah. So you think they're going to quarantine you?
Pretty positive.
Okay.
So I was just going to let y'all know before. You know what I mean?
Yep. Thank you.
Yep. I'm going to go let Coach Day know.
All right.
Have a good day, Coach.
See you, buddy. All right. Sorry, we got interrupted. If the zeros are these numbers, then the factored form of the polynomial is this. Okay? You will notice that square roots always come in pairs, plus and minus. So even if you'd only gotten square root of 5, you would have to know that negative square root of 5 is also a solution, so you would have to fill that one in yourself. So make sure that you always see square roots in pairs. Now, in class, what we're going to do is we're going to multiply this all the way out. So we're not done with this problem. You don't have to finish it tonight, okay? But we will finish this in class, okay? Number 5, the zeros are -2, 3, and 3. So P of x equals x plus 2, x minus 3, and x minus 3. Okay, this is called a duplicate answer because there's 2 of them, or sometimes we call that a multiplicity of 2. But anyway, that's x plus 2 times x minus 3 to the 2nd power, because there's 2 of them. And we will go ahead and write this out in standard form in class as well. We'll multiply it out. This one's kind of, well, I wouldn't say easy, but anyway, we'll work on this in class. I'm just trying to keep the video short, so I'm leaving the last step to do in class. All right, one more. P of x equals x minus 2, x minus 1, and x plus 3. And again, we'll finish this last step in class. Okay? Let's flip it over. All right. So, first things first, since we know, so when we're, let's look at this first problem. We know this is a degree of 3. So, since it is a third degree polynomial, because of this exponent right here, we know that it has 3 zeros, okay, or 3 solutions. Now, what we are going to do is we're going to use synthetic division to reduce the polynomial down to a second degree. One thing very important, we must get a remainder of 0. They have given us one of the solutions right here, -2. Okay? So here's what we do. We take synthetic division and we reduce this third degree polynomial down to a new polynomial that we can factor, hopefully. If you don't get a remainder of 0 right here, then this number right here, -2, is not a solution, okay? So understand that, okay? But I did get 0, so this polynomial, the new polynomial, becomes f of x equals, now it's 3x squared plus 7x minus 6. So now I'm just going to factor this to find the last two solutions. -18 and 7, so that'd be +9 and -2. So x plus 9 times x minus 2. Now I have to divide both of these magic numbers by 3. And so x plus 3 times, I'm not going to do the last step of bottoms up because I'm trying to find my zeros, so I'm going to make this equal to 0 actually. Okay, so my last two zeros are x equals -3 and x equals +2/3. Where's my third answer? Well, remember they gave me the one of the zeros. They gave it to me right here, so that's my third answer. X is also equal to -2. So those are my 3 zeros of this third degree polynomial. I did synthetic division to reduce the polynomial down to a second degree, and then I factored it. If I can't factor it, I'm going to do the quadratic formula. So once you factor the remaining quadratic, make sure you do one more step and solve the quadratic. Don't just factor it, solve it. So what did we do for this problem? We used synthetic division to divide the polynomial. We confirmed that remainder was 0. Then we got our new polynomial and we factored and solved for the remaining zeros. Okay? If we can't factor it, we might do the quadratic formula to get the remaining zeros. Okay? Oh, wait, here it is right here. I forgot I put this on my notes. I made this one myself, so if there's any mistakes, this time we can blame me. Okay? So these are the steps to, if we're given a factor or a zero, okay, how to find the other zeros. We'll do this second example in class. It's a little bit different. All right. So this is your first lesson on Unit 3, which is finding zeros. I hope you enjoyed it.